Hello friends, welcome back. We shall continue our discussion on IRC 78 Part 2, the limit state design of foundation. Till now we have covered the open foundation and pile foundation resting on soil for both cases of tension and compression. Now we shall continue with the piles resting on rock or intermediate soil. So we'll start with the compression first. So the behavior of pile foundation resting on rock. The code has given some description. I will read it out for you. So it says the load penetration curve of rock for medium strength, that is less than 100 MPa or equal to 100 MPa, has a large plastic component despite the brittle nature of rocks. And the displacement required to be fully mobilized such that the bearing capacity of rock shall be achieved, and which is very large, and such that a factor of 3 or 4 is required to limit the displacement to be less than 2% of the pile diameter. In case of very brittle rock which is more than 150 MPa, these do not exhibit a plastic load penetration curve, and once their strength is achieved, the point of failure is very brittle in nature. Hence, to limit the displacement, as such large displacement cannot be achieved at site, the serviceability limit approach has been suggested. Now, what we saw in piles for which were resting on soil, the ultimate condition or the ultimate limit state was the governing, and the serviceability limit state was following. In this case, the condition is reversed. Now, the serviceability limit state is the governing case, and the ultimate limit state is the following case. The allowable loads on pile under serviceability limit state shall be calculated from any of the following method, that is by calculation using the ground parameters obtained from site investigation or directly from the static load test. So we'll move forward to the serviceability limit state. And the calculation of pile capacity using ground parameters from site investigation for serviceability limit state. First, it says the ultimate capacity is to be calculated as per Appendix 5 of IRC 78, and to get the service capacity the base resistance shall be divided by 3, or and the socket friction resistance shall be divided by a factor of 6, and this service capacity is to be checked for uh, SLS rare combination given in IRC 6. It places additional checks that needs to be considered. First one is the base resistance shall be limited to 5 MPa, and for socket friction it shall be the actual length of socket, whatever the length of socketing we are doing, minus 300 mm, and this shall also be less than equal to the diameter of pile. For calculation of loads from static load test, we shall refer to the table 7, which again includes the correlation factors. For calculation of settlement, we shall follow the IS code 14593, and the limit for deflection or the settlement is given as in two cases, that is for pile dia with more than 600 mm, it shall be 2% of pile dia or maximum of 18 mm, and for pile diameter with less than 600 mm, the 2% of pile dia or maximum of 10 mm is the limiting criteria. Moving on to the ultimate limit state, it says for calculation of the characteristic capacity QU, the clause 9.1 of Appendix 5 of IRC 78 shall be used, and the design resistance or the design capacity is equal to the characteristic capacity divided by the resistance factor. The resistance factor is given in table 9. So there are again three factors: gamma B, gamma S, and gamma T. Gamma B is for base gamma S is for socket resistance, and gamma T is total. So if we do not calculate or we do not have the separate capacity for base and socket, we shall use the combined. Otherwise we need to divide the base factor, base resistance with gamma B, and the socket resistance with gamma S. Here the GR3 shall be used for load combination 1 and GR4 shall be used for load combination 2. The model factor in this case is 1.15. Again, very similarly, after applying all the factors, the base pressure shall be limited to 8 MPa and the socket length reduction of 300 mm shall be considered. Now the special situation of SV loading, that it says the factored ultimate capacity is to be factored by 1.25 for combination 1 and 2 in case of SV loading. So this was for the piles resting on rocks under compression. Now we shall move forward to the piles resting on rocks but under tension. So here the piles under tension, we have the ultimate limit state, the resistance factor, and we move down to the piles in rock and intermediate soil material. So the resistance factor is given for two cases, one is for single and second is for group. Again, in depending upon our methodology, how do we calculate the capacity? First is for shaft resistance. So for shaft resistance, nothing is specified. So we'll consider that we need to follow same as soil. It remains same, no difference. And second, for base resistance, if we see the base resistance, it says to refer to the table 9 for the partial factor of ground resistance with a model factor of 1.15. For calculation of pile resistance under tension by pull-out test, it again refers to the table 7 in which the correlation factors are given based on the number of tests. However, it says the CR3 and the CR4 is to be multiplied by a factor of 1.1. For base resistance, we shall refer to the table 9. Again, if we move forward to the group capacity, it simply says the uplift capacity of single pile into the number of pile will give the uplift capacity of the group of piles. So that was all in this video. We'll move forward and continue our journey on the IRC 78 part 2. Hope you like the video. Thank you.